Hello, good evening, everyone. So today we are last week of this problem solving session. So before start today's presentation, I briefly introduce about myself. So my name is Probin Maiti. I am PMRF student from Aizer Mohali. So the course you are taking, the name was Symmetry, Stereochemistry and Application, and course instructor was Professor Angshuman Roy Choudhury. So earlier classes we are talking about stereochemistry of organic molecule, how we can identify, we tells about that point group. Also we find out that some conformational stability. Then we are going to some reaction, and we also talk about some naming reaction also and some mechanism. Today's classes we are going to a different direction. So today's class we are solving some problem around the not the stereochemistry, it is about the crystal symmetry. All is that. So how the molecules are behave in three-dimensional, how it will be look like. So that's so today's we are looking about this. So when we talking about the crystal lattice, so the crystal lattice, like when the molecules are present in a three-dimensional, so how their lattice will be look like this may be cubic, and where the all the molecules are present in the center, like this is the primitive unit cell. So when we talk about unit cell, so there will be four type of unit cell. One is that primitive, one is the body center, that is that all are in that center, and there will be middle of the center, there will be one placement of one molecule. Then the face center, so in face center, so all the center are present in case of cubic, and all the phases, the molecules, the atoms are present. So like when you talk about the sodium chloride, so sodium chloride, that sodium and chloride will be placed at the center and face center like that. And there will be some C is the side center. So there will be total 7 crystal classes and 14 Bravais lattice. So that will be total 7 crystal classes like cubic, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic. So what the difference between this cubic, tetragonal, orthorhombic, hexagonal, monoclinic and triclinic? So when we're talking about the cubic crystal, so in cubic crystal it will be like this, your A, B and C, like this is your A, so this is your A, this is the B, and Z direction we call as C. So your A, B, C all are equal, and the angle between this alpha beta, so like this angle and this angle and above this angle, all are 90 degree. So angle between them are all are 90 degrees. So then it will be called a cubic lattice. So a cubic lattice, atoms are arranged in a cubic pattern, such as in face center cubic, like this one, face center cubic lattice, or body center cubic BCC, or a primitive cell. So in cubic, so there will be three type of possible. One is that primitive, one is face center, and one is the body center. Then the hexagonal. So in hexagonal, what are the difference? That A equal to B, but like this, A equal to B, so A and B are same, but your C is different. So A equal to B, but C not equal to B. So A and B are equal, but C are not equal. So then it will be hexagonal. So hexagonal, and that alpha beta angle is maintained 90 degree, but gamma is little distorted, it will be 120 degree. So if you show this here. So in case of hexagonal, so A and B are equal, but C is not equal, so only the primitive will be present and your gamma angle will be different. So hexagonal lattice atoms are arranged in a hexagonal pattern commonly found in the material like graphite and some forms of crystal structure. Then the tetragonal also similar, like A and B are equal, but here C is not equal. But your alpha, beta and gamma angle is 90 degree. So tetragonal similar like to a cubic lattice but the unequal axis length. So it will be almost like a cubic but unequal the axis length between B and C. Then next is that orthorhombic lattice. In orthorhombic lattice, what will happen? The rectangular lattice with an unequal axis length. So orthorhombic will be like this: A, B, C, which all are not equal, but alpha, beta, gamma angle between them is 90 degree, like this. A, B, C are all equal, but alpha, beta, gamma is different. So orthorhombic, that four types: primitive and body centered, also face center also present, and a side center also present. Then the case of monoclinic lattice. So in monoclinic lattice, the rectangular lattice with one axis inclined to the other two. So in monoclinic, like this one, so all the axes are not equal, but they are parallel to each other, inclined to the other two. One is inclined to other two, and where the alpha gamma is 90 degree, but beta is not equal to 90 degree, it will be 120 degree. Then the triclinic lattice, no parallel particular axis, no perpendicular axis, all the axes are different length and inclined to each other, like this triclinic. These are, so there will be no alpha, beta, gamma not are 90 degree, also that A, B, C are not equal, so that will be triclinic. And rhombohedral, in rhombohedral hexagonal lattice, one axis being the perpendicular to the rhombohedral face, like this. So then, so total number of crystal system. So we have the 7 crystal system. The one is the cubic, tetragonal, orthorhombic, monoclinic, triclinic, trigonal, and hexagonal. And axial length, if you shown for cubic, A equal to B equal to C. But in tetragonal, A equal to B, but not equal to C. Orthorhombic, A not equal to B, not equal to C. But alpha, beta, gamma all are 90 degree. For monoclinic, A not equal to B, not equal to C, but alpha, beta equal to 90 degree, but gamma not 90 degree. For triclinic, A not equal to B, B not equal to C, alpha, beta, gamma not equal to 1, not equal to 90 degree. Triclinic A, B, C are equal, but alpha, beta is equal, but they are not 90 degree. For hexagonal, A equal to B, but C is different. Alpha, beta is 90 degree, but gamma is 120 degree. So total number of crystal system is 7 and total number of Bravis is 3 plus 2 like 5, 5.9, 2, 11 and 3. So total number of is the 14. So total number of Bravis lattice is 14 and total number of crystal system is 7. So that you have to remember. So in triclinic, so there are only primitive cell, monoclinic primitive and site center, rhombohedral primitive site center, body center and face center. For trigonal rhombohedral, there will be only primitive one. For hexagonal lattice, only the primitive, and cubic lattice primitive body center and face center are present. So one face center lattice is C. So then if your question asks about that tetragonal F is a Bravais lattice or not, so you have to find out the tetragonal. So in tetragonal cases you have only that primitive one, primitive crystal lattice and body center. So there will be no face center and no one face center lattice for that tetragonal. So we can easily identify. For cubic cases also we cannot get any one face center lattice. So that we can easily give the answer. Then if you talk about that, what is the molecular symmetry and what will difference between the crystal symmetry. So molecular symmetry already you have known, there will be CN axis, like there will be sigma plane, SN improper axis of symmetry, all of this. But in crystal symmetry, like sir already told in your classes, so there will be crystal lattice and the crystal lattice have the 7. So total number of crystal lattice is 7, and so total number of crystal lattice is 7, and the axis symmetry are present is 1 2 4 6. The 5 rotation is not present, so there will be some rotational, some glide plane, some screw plane, all are there. So but they are not similar to the molecular symmetry. So when we talk about molecules and crystal, so they are totally different. Then so in questions, so maybe ask about the two-fold axis parallel. So when you talk about the two-fold axis is parallel to A, so which means the parallel to x-axis, then the coordinate xyz get converted to xy bar z bar. So two-fold axis parallel to A means so parallel to x-axis, so like this. So two-fold rotation and which is parallel to x, so x is not changing, so only changing is the y and z. So x is fixed, so y become y bar and z become z bar. But when you talk about two one parallel to b, so that means it will be parallel to y. So x y z become eventually become x bar y plus half, and like when you talk about 2 like 1, so that into b, so it will be like this. So x become, so your x y and z, so x is fixed because you b means so it will be parallel to y, so y become half. So the 2 1 parallel means it will be rotational and translational, so y become half and your z, so x will be changing and z will be changing, x become x bar, y become plus half because it's the 2 1 parallel, so one is gliding is present, so it will be glide half of the plane then z bar. So similarly, if you talk about the 2 1 around parallel to a axis like that x, so your x become x plus half, y become y bar, z become z bar. So if someone called about that your 2 1 parallel to parallel, so this is your parallel sign parallel to c, so then how it will be give you the point, so x y z, so x become x bar, y also become y bar, but you parallel to c, that means it is will be z axis, So when it will be z axis, so it will be z plus half. I hope all of you understand that. Similarly, when your plane is perpendicular, like your so your plane is perpendicular to M, so that means your x, y, z become x bar, y and z, and when it will be perpendicular to B, so like the starting point is x plus half yz, and it will be equivalent to xyz. Then write down the coordinate in terms of xyz for the symmetry element. So already we have told, like when your 2 1 that the gliding is happened around the y parallel axis, so x y z become x y plus x bar y plus half z bar. So your c is perpendicular to y axis, so x y z become x y bar z plus half. So when you talk about m plus m perpendicular to z axis, so your x y z become x y is same to z bar, like this. And twofold axis, x axis, so x axis means your x y z, so x will be remain same, but y and z is changing. So similarly we can also get the point like m perpendicular to y, so your x y z become x y bar z, like this. So today's classes all is about this. So you have any problem, you can talk. I hope all of you understand. So today's class is what we are learning. So we are learning about that lattice, the crystal lattice. So we have the seven type of crystal lattice, and if you called about seven type of crystal lattice, what the difference between that axis, length of the axis and the angle between them. If the angle is perfectly, all the length is similar and angle is 90 degree, then it will be cubic. And in cubic there will be three type of lattices present. One is the primitive, one is that body center, one is the face center. Then we talk about tetragonal, orthorhombic, hexagonal, monoclinic, triclinic, and trigonal. All of this. So in orthorhombic, your A, B, C are not equal, but your alpha, beta, gamma angle are 90 degree. So you have the 7 crystal lattice and total number of Bravais lattice is 14. Then we talk about that the tetragonal face center is Bravais lattice or not. As we shown here, the tetragonal lattice on the primitive and body center are the Bravais lattice, but face center is not. Face center and side center like that C1 is not a Bravais lattice. Then we talk about the difference between the molecular symmetry. So in molecular symmetry we that have that CN symmetry, sigma plane, essence improper axis of symmetry, but in crystal symmetry that are quite different. We have the gliding plane, rotational and transitional, and with the rotational symmetry about 1 2 4 6, not that fifth one. Then we talk about how that plane is converted when your plane is fixed xyz, and if you uh, your axis, if the two-fold axis of rotation, so what will be the uh, change. And then we talk about that we have the two-fold axis of cylinder and the one is the gliding plane. So then what will be happened, like when you have the two-fold rotation and that one gliding around the b axis, like your b, that is that y axis become y plus half, and x and z become opposite, so it will be called x bar and z bar. Like that we have also solving some problem regarding this. I hope all of you understand. So best of luck your final exam. So if you have any doubt we can talk. Then we also taking one extra 1 hour class session in the next week, so where we talk about, we can discuss about that problem regarding this, and also we can discuss about some of your doubts if you have. So best of luck for your exam, and thank you for the joining.